Okay, here's a problem like I had talked about in class where I'm going to ask you to write the top level module in Verilog. All right, so in this one I've more carefully laid out the diagram, and I've also given you the input and output definitions for both logic 1 that shows up in the diagram and also the overall top diagram. So you can see I have inputs X, C, output Y, and R defined in logic 1. And then for the top level, I've got a 3-bit input A scalar input N, a 3-bit output Y, and a scalar output S. All right, so the thing to notice here is that in this top level diagram, I'm also using wires. Okay, so I have W1, W2, W3, and we have to define those. So let's get started with our code. Wire, from the context I can tell that W1 is a 3-bit wire. All right, so I'm going to grab that and scoot that over. Okay, so it's 3 bits, 2 down to 0 for W1. And then I also have other wires, W2 and W3, that are scalars. That would be a semicolon. Okay, now I can start with instantiating logic 1 and logic 1 L1 and logic 1 L2. All right, so logic 1, the first instantiation, I take a look at the diagram, that's the whole point. X is connected to A, so you can see that here, and then N is connected to C, and then Y would be connected to W1, and then finally R would be connected to W2. All right, so logic 1 is instantiated. Okay, do the same thing for logic 1 L2. The second instantiation, X is connected to W1, C is connected to W3, Y is connected to Y0, R is connected to S. All right, and then the only thing that's missing is we have this AND gate that shows up, and we need to make an assignment to get that net list instantiated in the design as well. Okay, so I can type or write assign. Okay, and what I'm going to do is assign W3 as W2 ANDed with, put an AND sign, that's supposed to be an ampersand, ANDed with N. All right, so that's it. It's a fairly simple process, but I want to make sure that you can do that, so I want to put that on exam 1.